Hello, Matt Davis here with some more homework quiz help. This one is from section 7.2. When a certain pasta company bags and produces its bags of spaghetti, 5.72% of the pieces of spaghetti end up getting broken. Suppose that 200 pieces of spaghetti that have been bagged are randomly selected and that the number of broken pieces is counted. What is the chance that the sampling error will be less than 2 percentage points? Round your answer to 4 decimal places. All right, so the first thing we're going to do in the interest of giving help rather than answers is change this sample size from 200 to 180. And that is the sample size, so we'll go ahead and label that as n. And then instead of looking at the chance that our sampling error will be less than 2 percentage points, we're going to change that to 1.5 percentage points. All right, so getting into this, the key part at the beginning is translation. We need to make sure that we understand what kind of question they're asking us. If we head in the wrong direction on the question, there's no chance of getting it right. So speaking of chance, they're asking us what is the chance. So that means that they're asking us a probability question. So we're going to start off by writing probability of something. And then we look at our context here. They're giving us the proportion of pieces that are broken. That is the population proportion P, 0.0572. So we have N, we have P, and we also see that they're counting the number of broken pieces. So we're in an NPQ situation, which is our proportion situation. So when they talk about our sampling error being less than 1.5%, we can just translate that. They want the probability or chance that the sampling error will be less than 1.5 percentage points. But when we work with percentages, we want to change that to decimal form. So we're going to actually look at what's the probability that the sampling error will be less than 0.015. Sampling error can mean different things. It depends on our context. We're in the context of proportions here. So when you're doing proportions, you're using a sample proportion P hat to try and estimate a population proportion P. So when they talk about the sampling error being less than 1.5 percentage points or less than 0.015, they're asking about the probability that our P hat would be less than 0.015 away from the true proportion P. So doing some more translation on this, probability that P minus 0.015 would be less than P hat would be less than P plus 0.015 is what we want to answer. So we're talking about the chance for sampling error when we're in a proportion setting. So it's going to be a probability about what kind of P hat we get. We want the sampling error to be less than 0.015. So that means we can miss the right answer by as much as 0.015 below, or we can miss the right answer by as much as 0.015 above. So that's why we're doing the plus or minus there. All right, so going back and finishing the translation off, we know the value of P, so we can plug that in. So they're asking the probability that 0.0572 is minus 0.015 is less than P hat is less than 0.0572 plus 0.015. So I'm just plugging in that value of the population proportion in place of P. And then we can simplify the addition subtraction. I'll skip the calculator part on that, but if you do the subtraction on the left, you get 0.0422. We have P hat in the middle, and then doing the addition, we get 0.0722. So we haven't actually started really calculating the probability. This has all just been translation, but it's really the key step. If you get to here, most people do end up getting it right. So I think the most common mistake that people make on this problem is just heading in the completely wrong direction and doing some process other than what I've just shown you. So this is the key, I think, getting it set up correctly, but let's finish it off now. So if you want to calculate a probability for P hat, you need to know its distribution. And in the problem before this one, we talked about the distribution. We checked NP and NQ, made sure they were both bigger than or equal to 10, and they were. And with my changes in sample size, that's still going to be true with these numbers. So You check your NP and NQ to make sure they're bigger than or equal to 10, and then that tells you have a normal distribution. If you have a normal distribution, you can use that to calculate probabilities. But to do that, you have to get z-scores, which means you need mean and standard deviation. So doing that, the mean of the p-hat values would be equal to p, which is 0.0572. And then the standard deviation of p-hat would be the square root of p times q times n. So we will go to the calculator for that one. So let's jump over there real quick. So we want the square root of p, which is 0.0572. Missed the 0, so we'll fix that, 0.0572. And then times 1 minus p. So 1 minus that would be 0.9428. Divide that by our sample size, and we're working with 180 on this problem. So there is our standard deviation of p-hat. We need 5 significant figures, and that first 0 doesn't count on a small decimal number like this. So our 5 significant figures will be the 1, the 7, the 3, the 0, and the 8. The 8 is followed by a 9, so it'll get rounded up. So we're going to put 0.017309. So sigma of p-hat is 0.017309. All right, so now we start actually getting to work on the probability. Drawing our normal shaped curve for p-hat, putting the mean of p-hat in the center, which is the true value of p. Our two boundaries, on the left we have 0.0422, on the right 0.0722, and we want the area in the middle. So that's what we're trying to find right there. So we need to get z-scores to make that work. You can start off finding the z-score on the left. So this z-score would be the boundary, 0.0422, minus the mean, 0.0572, divided by the standard deviation of the p-hat, 0.017309. This is where we really need those 5 significant figures, so we can trust 4 significant figures if we need something like a first digit in 3 decimal places. So now we go to the calculator and we see what this z-score is. So parentheses around the numerator on z-scores. Plugging in the boundary and the mean, and then dividing by the standard deviation. And then 3 decimal places on this, so that'd be negative 0.867, because the digit after the third one is bigger than 5, we're going to round up. So taking that back over, right here we have negative 0.867. So when we did our 2 boundaries, we added and subtracted the same value from the mean, which means this right-hand z-score is going to be equal but opposite direction. So give myself a little more room here. So z2 will be the same thing, only positive. You can check that on the calculator, but you should end up seeing that that's true. All right, so we're almost there. We want this probability, which is this area in the middle. That area in the middle comes from NCDF, so I'll go ahead and calculate that down here where I have a sliver of space left. So NCDF of our left-hand z-score, negative 0.867, to our right-hand z-score, 0.867. And then go to the calculator, and that's going to end up being our final answer. So let's go see what we get. So we know boundaries, we want to find area, so we go into the distribution function and choose normal CDF. We put in our left z-score, making sure we use the negative key rather than subtraction, and then our right z-score, same thing, but opposite sign. We press enter, we get 0.6140, but followed by a 5, so 0.6141 is what we're going to go with. And that's going to be our answer. So that's the part that we would end up putting into active learning. So pretty long process on this one. When you're doing this, you will have already calculated mean and standard deviation on the previous problem, and you'll have already kind of sorted out distribution. But there's still a lot to do anyway. We got to think about what setting we're in, proportions or means. We have to translate correctly and then know how to break that translation up into a probability statement that we can work on by adding and subtracting that amount of acceptable sampling error from the true mean, the true proportion, add and subtract it, and then our p-hats in the middle. Once we do that, we're kind of back in the chapter 6 setting of just trying to find the area between two boundaries. We just have to make sure that we use the right mean and standard deviation, and the mean comes from u of p hat equals p. Standard deviation comes from the square root of pq over n. And then make sure that we use that mean and that standard deviation when we're calculating our z-scores. All right, other little things, I guess. Be careful when you round your standard deviation. Remember that first 0 doesn't count, so you need to go 5 significant figures after the 0. And then z-score rounding, making sure that you put 3 decimal places on those exactly. Those are all little things that could cause this to go wrong too. All right, whatever tripped you up, I hope you saw the solution to it here. Good luck as you head back to the quiz and try this one again.